Right, the next video is talking about reconstructing genetic family 1. Now, genetic family 1 is the family that whose members all go back to Limerick at the beginning of the 1800s, and we've established that because we are all genetically related to each other, we can piggyback on certain families who have a connection to the Hartwell Spierin family of early Limerick in the early 1700s and late 1600s. The approach that we take to reconstructing these early Limerick Spierins is to find the missing 3 to 4 generations between the brick walls in the current family histories, and here we have Ontario 1, New Jersey, Limerick, Australia, Dublin, Ontario 2, Ontario 3, Philadelphia, and Georgia, and these red bricks represent the brick walls that each of these respective families has identified in their family tree. The yellow boxes down here are the people from each of these families who have undertaken a Y-DNA test. We know that Ontario Family 1 links back to Matthew, Luke, and Nicholas, who were probably born around sometime in the 1660s, and Matthew passed away in 1726, Luke in 1719, but from their wills we've been able to put together a family tree of about 5 generations relating to their children. Now, there are still 3 to 4 generations missing between these children and the brick walls currently in each of these families in genetic family 1. So, can we figure out who is related to who, and can DNA help fill in the blanks? That is the big question. Now, there are various markers that may be useful. So, for example, various members have a mutation on specific markers that are indicated here, and based on these specific mutations, it should be possible to generate a cladogram, also known as a phylogram or phylogenetic diagram, also known as a mutation history tree. But can such a cladogram distinguish between the different family branches? Well, having done the exercise, and this is an updated figure based on the one that is currently on the website, it would appear to be unreliable and too crude. 111 markers is not enough to actually distinguish between the different families. It would be more accurate if more markers were used. But to upgrade from 37 markers to a 67 marker test costs $99, and to upgrade to 111 markers test costs $220, so it would be $319 US per person, and that is not something that I would like to recommend to all the members in genetic family 1. It would be much nicer to wait until the price comes down considerably before making such a recommendation. Also, even if people did upgrade, there is no guarantee that more markers will be any more discriminating and will be able to break out the different branches associated with genetic family 1 than we currently are able to do with the lower resolution tests. There's also a big problem that we have with back mutations and parallel mutations, because these can really mess things up. And so for that reason, time to most recent common ancestor estimates have wide ranges and can be misleading, because one person may mutate forwards, say from a value of 16 to 17 400 years ago, and then 100 years ago somebody else might, one of the descendants might back mutate from 17 to 16. So if that person matches somebody who is also 16, they may look a lot more closely related than they actually are by virtue of this back mutation. And the same thing applies to parallel mutations as well. So there's always this possible risk of convergence, where you get two people converging on each other. The genetic profile converges and makes them look a lot more closer than they are in fact. They actually are. Alex Williamson has done some very good work with his big tree, and this is using SNP testing. Now, we had 111 markers for STR testing. We have 50,000 markers with SNP testing, and these may turn out to be surname specific, branch specific, family specific, and even person-specific. So they can be a lot more informative than what we're currently using with yDNA STR markers, from the point of view of trying to separate the different family branches out. And in this particular example, you see from my Gleason family tree that the Gleasons seem to be characterized by these 5 specific SNP markers here. But like I said previously, the big Y test costs $425 US in the sale, and it might be wiser to wait for a deep clade panel, but we've no idea when that might be. If it does become available, it's likely to be a lot cheaper, maybe $100 US, and that would be a lot more affordable than forking out $400. But again, we've no idea when that might be. For now, the best thing to do would be maybe to have 1 or 2 people in the group act as a proxy and have the big Y done. And preferably that should be somebody who has tested out to 111 markers, and preferably people who are separated by geography, by location, as far away from each other as possible on the Spearin family tree. So there's a little bit of guesswork involved there, because we're not entirely sure who are the most distant relatives, and we would have to just make our best guess. So one other possibility is to actually combine the SNP marker tests with the STR marker testing, and this is something that Nigel McCarthy has really championed in his McCarthy Surname Project. And you can see here that there are 3 Gleasons and a little. There's 2 Gleasons here who are brothers, in fact, and by using a combination of the SNP markers and the STR markers, Nigel has been able to split out the various people in this group into the most likely branching pattern. Now, such a branching pattern will eventually be possible with the Spearin Surname Project, but only when we have identified the SNPs that are specific to genetic family 1, and only when more and more people have actually done the test. It's probably a few years before we would recommend for everybody in the Spearin Surname Project to do a specific deep clade panel, but we will eventually get there, and we would certainly give that particular impetus a boost by testing 2 people with the big Y test, and that's something we will do shortly. So fine-scale SNP testing is probably the best method of determining branching patterns within a genetic family, and certainly within genetic family 1 of the Spearin Surname Project, but how to do it as cheaply and efficiently as possible is still a challenge. So for now, we will just concentrate on doing the big Y test. The third type of test, of course, is autosomal DNA, and it has been raised as an interesting possibility. Can it actually help us find who is related to whom within the project? Now, I've done my autosomal DNA. It goes back to about the level of my 4 times great-grandparents. I've also done my dad, which gets me back an extra generation, and I've done my mother's sister, which gets me back an extra generation. So altogether, I've tested quite a few people within my family. This is me down here, and then there's my dad. I've tested 4 of my siblings and also my sister's daughter, but we are all connected to Patrick Spierin via that particular ancestral line, going back up to his marriage to Mary Morgan around about 1828 or so. But there's also other people within the family that I've tested, such as my dad's sister Jackie, who would also be related to Patrick Spierin. Cormac, my dad's first cousin, who's related to Patrick Spierin. Then there's Kathleen, and there's also Owen. All of these people descended from Patrick Spierin and Mary Morgan. So the question is, can the fact that I have tested these 4 people give some information about who I am, who else I might be related to genetically in the database? And that's where we triangulate on a common ancestor. And the common ancestor in this situation is actually a common ancestral couple, Patrick Spierin and Mary Morgan. And the theory is that anyone who matches any two descendants of Patrick Spierin and Mary Morgan has to be related, with a caveat, via a common ancestor at or above the level of Patrick Spierin and Mary Morgan. And that caveat is unless it's a false positive match, or unless there's a second connection between any of these two people, and that can really throw a spanner in the works. But you'll see now why it's called triangulation, because we are triangulating, creating these little triangles between the descendants of a particular ancestor and that ancestor himself. So looking at the number of matches that Dad has in common with Owen, there's 13, Cormac and Owen have 15, Kathleen and Owen have 22, Dad and Kathleen have 17, Cormac and Kathleen have 34, Dad and Cormac have 53 because they're first cousins, whereas everybody else more or less has a second cousin relationship to each other. So being first cousins, you will share a lot more. Some of these first cousins will be related via the Spearin side of the family, and some of them via the O'Carroll side of the family. So one way that we could separate out those two would be to look at a specific O'Carroll family member, see what matches we have with him, and subtract any of those from this particular group of 53 here. And like I say, any two descendants have to be related via a common ancestor at or above the level of Patrick Spierin and Mary Morgan, and that could be either on the Spearin side of the family, which is this family tree up here, or on the Morgan side of the family, which is this family tree up here. Now, I've written to all of those, I'll just go back, I've written to all, there's about 90 people, when you take into account a degree of duplication among these matches, there's about 90 people that I've written to who are matches at or above the level of Patrick Spierin and Mary Morgan, and most of them have no idea how they are related to these two people, but one person has written back and said, actually, I have a Morgan in my family tree, and it is just about the right timing to be a sibling of Mary Morgan. So maybe we're related to these people by Mary Morgan's parents, and that is something that I'm currently actively investigating. Within a family branch, autosomal DNA testing can help break through the brick wall. So that's what you see in this last example. I'm using autosomal DNA testing to help break through my own particular wall. And this can be done with any of the families within genetic family 1. So any family that has had several people do an autosomal DNA test, they can also do a similar type of triangulating exercise to see if they can break through the brick walls at their particular brick wall level. But can it tell which branches are most closely related to each other? And that is really the question we want to find out. So here is a diagram of the matrix of autosomal DNA matches among project members. And I've put in the particular initials for each of the project members, and you'll probably recognize some of your initials up there. And just to make it a little bit clearer, I've changed the text into colored boxes and put the number 1 for first cousin, 2+ for second cousin or greater, yellow is a 3, third cousin or greater, and orange is fourth cousin or greater, and then purple is fifth cousin or greater. And what you'll see is that, so for example, my dad matches his first cousins. This first cousin here is quite interesting, because if we go back to the diagram, this is my dad's cousin Betty, and there's my dad, there's his father, there's his father, and cousin Betty is descended from my father's father. So she is on my father's paternal side of the family, whereas the Speirins are all on my dad's maternal side of the family. Now, if we go forward, we find that cousin Betty, this one here, matches my dad, as you'd expect, on the paternal side, but also matches, at a fifth cousin level, somebody in the Spearin Project, and another person in the Spearin Project, and another person in the Spearin Project. So it's looking that myself, or my dad and cousin Betty, have a double connection. She is his first cousin on his father's side of the family, and possibly his fifth cousin or sixth cousin on his mother's side of the family. So one does have to be aware of the possibility of these double connections that can throw a spanner in the works. But you see also then, as you go down through each of these members, that there are associations between them, and it is indicating that the various family branches are related to each other. Well, we kind of knew that already from the y-DNA testing, so is this telling us anything new? And these are the actual families that these people belong to. So you can see that, for example, the members of Ontario 1 are clustering here. This person here, Karen, matches Susan and Fergus. Susan matches my dad's cousin Betty, as well as Karen and Fergus. And Fergus matches Karen, Susan, and also Brian in Ontario 3, and also Joe in Limerick 10. So Fergus is linked to a lot of these families. But then we come down to James in, Bob in New Jersey, and also to Neil in Australia, and they don't match anybody. So this possibly indicates that these branches are more further away from the rest of the group than the others. But it is not necessarily a given, because the luck of the genetic lottery could simply mean that they are as closely related as anybody else, but just weren't lucky enough to inherit the same DNA segment that other people inherited. So there's very little that you can tell using autosomal DNA over and above what you already know from y-DNA testing, except in a situation where a particular family, so for example, Fergus's family, his great-great-great-grandmother is Harriet Spierin, and he doesn't know who the parents are, but autosomal DNA testing clearly shows that he is a close relative to some of the other families, and that is good circumstantial evidence to suggest that his particular branch of the Spearin family is also related to the Speirins of Limerick. So it can be useful in that particular situation, where it can link branches with no y-DNA candidates to those branches that have y-DNA candidates. We can also look at reconstruction using other markers, such as locations, forenames, religion, occupation, in-laws, and new records are always becoming available, and we know that we have to explore the Earl of Dunraven's estate papers as well as Lord Southwell's estate papers for the years 1660 to 1860, and it is very, very likely that we will discover more in these papers, but these are the rarer documentary resources, and they're not as well indexed, and they're not available online, and they will be a lot more difficult to peruse. So that is going to be a big project for one of these summers in the near future. So, to summarise, y-DNA unites us all. We have a common ancestor in Limerick. DNA helps focus our further research. It may reveal eventually our surname's origin, but we're not there yet. Family reconstruction is possible, and we will be able to find out, hopefully, the missing 3 to 4 generations between each family's brick wall and the early Limerick Spierins of the early 1700s. But we're still at early days, and new records will always become available, and these will definitely help. And certainly our family has taken us on a unique and exciting adventure, and it ain't over yet.